Hi, in today's tutorial, we want to continue with our series of questions under real valued function. Today, we'll look at the function f that takes x and maps to 1 plus x all over 1 minus x, where x should not be equal to 1. Okay, we know why we insist that x should not get the value 1. So A, find the inverse function f inverse of x. B, show that there is no value of x for which the inverse function is equal to the function f of x. All right. So our function again is the function f that takes x and maps to 1 plus x all over 1 minus x. X is a real number, and at the same time, x should never be equal to 1. Why should x not be equal to 1? You see, if x takes the value 1, then you see the denominator will become 1 minus 1, which will be 0. And remember, dividing by 0 in mathematics is absurd. All right, it's impossible. So we always avoid a situation where in any rational expression, the denominator should take the value 0. That's why we say x should never be equal to 1. X can get any other real value, but x should never be equal to 1. All right. Let's start with the first part. The first part of our question says, find the inverse function. How do we get the inverse function of x? Remember the 3 steps method? Step 1, we'll let y be equal to the function f of x. So y be equal to 1 plus x all over 1 minus x. We solve for x. All right, this is a fractional expression. All right, we just do this all over 1. So that we'll have a fraction equal to a fraction. Then we'll carry out cross multiplication. This expression multiplied to that, we have y into 1 minus x equals to 1 multiplied to that expression, we have 1 plus x. Open the parentheses. Y multiplied to 1 is y. Y multiplied to negative x is negative yx. All right. Now we bring all the x's to one side. Remember, we are saying we want to solve for x. That means we should have x alone on one side of our expression. So all right, this is negative yx. If we take it that way to come and meet this one, and we take this one this way, all right, this one is going to come this way, and negative yx will go that way. Okay. Remember that each time we cross the equal sign, the sign in front of our expression, we will move from negative to positive, if that were the case, like this one, or from positive to negative, in the case of plus x here. Place of plus 1 here. All right, so this is positive 1 coming over this way will become negative 1. This is negative yx going over that way, all right, will become positive yx. Now we have x in this expression, x in this expression. We can factorize out x. It factorizes into 1 plus y. All right, so to have x alone, we simply divide both sides by 1 plus y. We divide here by 1 plus y. Come and divide here also by 1 plus y. All right, so if we look at it, 1 plus y, the same expression, it cancels out. So we can see x equals y minus 1 all over 1 plus y. This is the expression for x. The final step now is to get our expression. Therefore, our inverse function will now replace y with x in this expression. We'll replace y with x. In that expression, we'll get our inverse function. All right? That is our inverse function. But it's not complete. We have to define it in a similar manner. So we can say it can be written as f inverse that takes x and maps to the expression x minus 1 all over 1 plus x, where x is a real number and x should not be equal to, what is the value of x that will render this denominator 0? To get that value, simply set this denominator to 0 and solve. So if you set 1 plus x to 0, we take this positive 1 that way, it means x is equal to negative 1. So this is the value we have to avoid. So x will not be equal to negative 1. All right, so the inverse function that is defined in a similar manner as our function f. So we've done the first part of our question A. Now let's look at the second part. The second part says show that there is no value of x for which the inverse function equals the function itself. So we want to solve this equation. F inverse equals f of x. We want to solve that equation. What is that equation? So what our f inverse? Our f inverse, this is it. This is the expression for f inverse. So we're saying x minus 1 all over 1 plus x is equal to our f of x. That's the expression for f of x is equal to 1 plus x all over 1 minus x. This is a rational equation that we have to solve. We have to demonstrate that there is no value of x for which there is this equality is valid. We want to show that this equation has no solution. That's another way of saying asking the same question. To say that there is no value of x for which this expression is valid is also to say that this equation has no solution. Let's show that. Let's make space here. Okay, this was question B. Let's carry the expression again here and work clearly. X minus 1 all over 1 plus x equals 1 plus x all over 1 minus x. This fractional expression equals this fractional expression. We carry out cross multiplication. All right. This expression multiplied to that expression, we simply write it as x minus 1 multiplied to 1 minus x. This expression multiplied to that expression, we write it as 1 plus x into 1 plus x. All right, we open the parenthesis. This x multiplied to 1 is x. X multiplied to negative x. Make sure that we don't mix up with our signs. This is negative x. So x multiplied to negative x squared. We are through with this. We'll now go to the negative 1. Negative 1 multiplied to 1 is negative 1. Negative 1 multiplied to negative x. Negative multiplied to negative is positive. So I have positive x there. Open this other parenthesis this way. The same activity. We take this first member and open out that parenthesis. Take the second member and open it. Let's start with the first member. The first member here is 1. 1 multiplied to 1 is 1. 1 multiplied to x is x. We are through with this member. We take the next member. This member is x. X multiplied to 1 is x. X multiplied to x is x squared. Okay. All right. So now let's bring like terms together and simplify our work. So we have here x plus x. That gives us 2x. All right, minus x squared minus 1 is equal to 1. We have x plus x again there. That gives us 2x. All right, 2x, 2x. You see that if we subtract them from both sides, they will just go away. All right. If we take this one this way, it will become 2x minus 2x. If we take this one this way, it will become 2x minus 2x. So they just go away naturally. We are left with negative x squared minus 1 is equal to 1 plus x squared. All right, now let's bring the x squared to one side, okay, and take the ones to the other side. This x squared, we'll take it this way, or we'll take it this. If we wish, we can take this one this way. Whatever direction you go, you have the same result. Negative x squared, take it this way to come and meet the corresponding x squared there. And let's put the arrow. And positive 1, we take it this way to come and meet that negative 1. All right, remembering that each time we are crossing the equal sign, the sign in front of our quantity moves from positive to negative if we're positive, or negative to positive if we're negative. All right, let's perform the procedure. Negative 1 is here. All right, this is positive 1. Coming this way becomes negative 1. This is positive x squared is there already. This is negative x squared. Moving over this way, it becomes positive x squared. Negative 1 minus 1 gives us negative 2. X squared plus x squared. There is one of it here, there is one of it here. So we'll add 1 plus 1, it gives us 2. So there are 2x squared. Since it's the same term. They are like terms. All right, so we have negative 2 equals 2x squared. Remember, we want to solve for x. Is it possible to have a value of x that will render this equation valid? Is there any value for x? Let's check. Let's check and see. We have negative 2 equals 2x squared. Now, if we divide both sides by 2, remember I want to look for x. If we divide here by 2, we also divide here by 2. That 2 cancels off. 2 here, 1, 2 there. So we have negative 1. Negative 1 equals x squared. What next to do? We want to solve for x, so we have to do away with the power 2. What's the opposite operation of square? The opposite operation of square is square root. So to do away with this square, we take square root of both sides. So let's take the square root of this, and we take the square root of that. Now the square root cancels the square, we have x. But looking over here, square root of negative 1, it doesn't exist in the number line. It doesn't exist in the field of real numbers. This is simply I, the imaginary number I. And since we are working on the set of real numbers, that tells us therefore that there is actually no value of x. No value of x for which the inverse function equals the function value. No value of x.